Oh, well, thank you for joining me. I've got a request for this solving equations. And this time we're going to be looking at when we have an x squared equaling some number. So this is not what's called a linear equation. This is called a quadratic equation because it's to the power of 2. Question here is, what number times itself will equal 16? Now, for those of you who straight away can see the answer, you might say, well, x equals 4. And if you stopped right there, you would only get half a mark, because it is true, but there is another solution. Because when you have two numbers, which is x times x to equal 16, it's also possible that both those numbers are negative, because a negative times a negative is also a positive. So in fact, there are two answers. So x could equal 4, or x could equal negative 4. So when you have x squared equal a number, you've got to remember that there are two possible numbers that can multiply to equal a positive value. They're both positive, or they're both negative. Well, let's have a look at another question. Question 2, we'll call it question 1. And let's say that this time we say x squared equals 36. Now, I'm going to add a step in here. I'm going to say that x equals, I'm going to take this squared over to be plus and minus the square root. So when you have a square over here, it will become plus and minus square root on the other side. It's still got a 36. And therefore your answer will be x is positive root 36. Square root of 36 is 6. So the answer is positive 6, or x could be negative 6. And it's a little bit flash, but you could write it like this, a plus and a minus 6. That's also another way of writing two numbers. That's a positive 6 or a negative 6, where they say plus or minus 6. That's an unusual way to present it, where you've got a plus sign sitting on top of a minus sign. So, are we starting to get the idea? Let me do another one. Let me do question 3. And this time, I would like to solve x squared equals 81. Now, for those who already can see it, is there one answer or two answers? I'm going to take that square across from being a square here to being plus or minus the square root on the other side. So when you take a square across to the other side, it is, I can't remember which color I was using, square root of 81. That's a positive square root of 81, or a negative square root of 81, and the square root of 81 is 9. So it's a positive 9, or x equals a negative 9. Of course, you don't need the positive. If it is a positive, you could just say x equals 9, or x equals negative 9. And yes, for those who just may understand that last step, you could say x equals plus or minus 9. That's also correct. Now, let me do one more before I finish, because not all numbers have a square root. So not all numbers work nicely like the square root of 16, because they're all square numbers. So far, I've used a 16, I've used a 36, I've used an 81. Now, they're all square numbers. So let's say we want to solve x squared equals, say, 7. Well, x equals plus and minus 7. So therefore, if you wanted to write them separately, x equals root 7, or x equals negative square root of 7. And that's all you can do. Of course, you can get your calculator and get the square root of 7 on your calculator and say 2.64. But if you write 2.64, you have to say, or 2.65, because rounded off to 2 decimal places, negative 2.65. It's important that you say, first of all, that it's rounded off to 2 decimal places, and you cannot use an exact. You cannot write exactly. You could write approximately 2.65, or x is approximately negative 2.65, but the only way you can answer exact is if you leave the square root sign in the number and answer it, make it look like that. That's a special number. We call that a surd. So you can have square root of 7, which we know is about negative 2.65. Negative square root of 7 is close to negative 2.65, but not exactly. It is exactly root 7. It is exactly negative root 7, but it's only approximately 2.65 and approximately negative 2.65. All right, so I hope that's helped. Until I talk to you again, stay happy.